This video is meant to show you how to analyze combination circuits. Combination circuits are a combination of resistors where the resistors are not all in series or all in parallel with each other. We define series as saying that the current had to travel through each resistor. Well, if I look at this circuit here, the current comes out of the battery, travels through the 5 ohm resistor, but then has an option of either going through the 3 ohm or the 12 ohm resistor. Because it has that option, this combination is not in series. We said that a parallel circuit was a circuit where current could travel through only one resistor. Well, again, if the current comes out of here, it is forced to travel through the 5 ohm, and then it would travel through one of these two resistors. So it's not going through only one resistor, it's going through multiple resistors. Therefore, this can't be just series or just parallel, so it is a combination circuit. The first thing we will do with this combination circuit is find the equivalent resistance. As you work through this process, every time you combine resistors, you need to draw a new picture. You'll notice here we will only draw one additional picture, but in the next example problem we will have a few more. This is a fairly simple combination circuit. As I look at the circuit, any combination circuit, I want to look for two or more resistors that are just in series or just in parallel with each other. The first set of resistors that I notice like that in this circuit are the 3 ohm and the 12 ohm resistors. The current would either go through the 12 ohm or through the 3 ohm resistor. And so those are considered to be in parallel because the current goes through either one or the other. So I'm going to combine those two and draw just one resistor in its place that has the equivalent resistance. Go ahead and pause the video right now and calculate that equivalent resistance for the 3 and the 12. You should have gotten 2.4 ohms. Adding all of these resistances up, because they are in series with each other, I get an equivalent resistance of 13.4 ohms. I'm done with the first step in this process, and my next step is going to be to find the current and voltage through each resistor. To do that and to organize my answers, I'm going to create a chart just like we learned to create the other day in class. I'm going to list each resistor in numeric order, and I only use the resistors from the original circuit, nothing from the new circuit that I drew. So 3, 5, 6, and 12 are my resistances. I will also include a row for the totals of the circuit. So the total resistance or equivalent resistance we said was 13.4 ohms. The voltage of my circuit is 5 volts. And I now have 2 of the 3 things in that row, which means I can find the third. 5 divided by 13.4 gives me the current, which is 0.373 amps. Now I'm going to look back at the last picture I drew. These 3 resistors are in series with each other. We know current is constant in series. That means that whatever current I had traveling through the battery, 0.373 amps, is also traveling through each of these resistors. I'm going to mark that right next to their resistances. now know the resistance and the current traveling through each of these resistors, and so I can find the voltage. Go ahead and do that. Pause the video, calculate those for yourself, and then replay once you have those to check your answers. Hopefully your answers match up with the ones that I have written here next to each resistor. I now know everything I could possibly know about each of the three resistors in this picture, and so I will scroll up to my original picture. The 5 ohm resistor here is this same 5 ohm resistor here, and so I can put that information in my chart. The same goes for this 6 ohm resistor right here. It's the same as the one down here, and so I can put that information in my chart as well. I'll go ahead and do that right now. I'm left with this 3 and 12 ohm resistor right here. I don't have information about them yet, but I do know that they are connected in parallel. Voltage is constant in parallel. That means that as current travels through either the 12 or the 3 ohm resistor, it must go through a voltage of 0.896 volts. That's the number from right here. So the voltage of the 3 and the 12 is 0.896. I'll write that in my chart. I just realized I made a mistake. I put the wrong voltage in for the 6 ohm resistor. So I'm going to fix that. Okay, all fixed. Now I'm only missing 2 spots in my table. That's the current for the 3 and the 12 ohm resistor. Go ahead and pause the video to calculate those right now. So here are the values. Again, each of these values are found by using V equals IR. So V divided by R gives me these values. I've now completed this problem. I have a full chart that shows my equivalent resistance as well as the voltage and current in each resistor. This is how you will get your answers for any of these combination circuits. The next video will show you another example that's a little bit more complicated.